There. So on this problem, this is kind of a cheat code. If you've been teaching math for a while, you remember this one all the time. Remember the limit of the sine of x over x. The limit as x goes to 0. Okay. And so you were probably told that this was 1 back in the day. And you can see that graphically because here's 1 and here's sine of x over x, right? And so you're like, geez, it's basically the same function as you approach it, and that is they're getting to 0 at the same rate. Later, you learned about L'Hopital's theorem. So if you take the derivative of the numerator over the derivative of the denominator, and you, lo and behold, you get cosine of x. Take the limit of that, and you get 1. And that's cute when it's that in that format. Now we can use the same thing here because it's just the limit of this, the sine of x over x. Well, if I just let u equal x squared plus y squared, then I end up with the sine of u over u, as long as u doesn't equal 0. And if that's the case, then again, it's the limit is 1. Ergo, this fills in the blank, right? That's the situation. I think the question was, is this a continuous function if it's drawn up this way? I don't have the directions in front of me, but that's the gist of it. Now, the other thing you can do, of course, is you can actually take a couple of different things you could do here. You could do it in Excel, which I'll do in a minute. The other thing you could do over here is you could say, well, listen, if you're approaching x and y like this, and this particular one is fine, you could come down the x-axis. You could let x equal 0, or y equal 0, rather. And then you could just come down the x-axis. And if you did that, lo and behold, you're doing exactly what I just did here. Okay? And that's easy to do. And the same this way here. If you let this be let x equal 0. And that would work on this one because of the fact that if either one of them is 0 by themselves, it's okay. And so you could kind of come out from that standpoint. Or you could say, hey, well, what would happen if you come down to the equations y equals x and y equals negative x? And well, if you did that, you would end up with the sine of 2x squared over 2x squared. And again, it's the same basic premise. You can just say, hey, this is x. And then you're like, that's x. And so there you go. In Excel, of course, if you're going to do it in Excel, you need to set it up kind of like this. Again, you can do it any way you want, but I like to put my 0 here, the one I'm approaching here, and I just go equals this guy minus 0.01 or something. And then drag it both ways and see what happens. Whee! And whee! Well, that's not going to work, Jay. Oh, fiddle faddle. Equals this guy plus 0.01. That would work too, I guess. And then what are you doing? Oh, for God's sakes. That's right. Never mind. Escape. Undo. There you go. That's hot. All right, so 0's here. I think that's where I had it initially, so that's cool. Nope. And then equals this guy plus 0.101 rather. And drag it this way if you want to. Okay, cool. And you can just copy them since we're both headed towards 0. I don't really care. Control C, Control paste transpose. That's cool. So equals the sine of x. And you have to hit function F4, J. Function F4. I want it to be in row 1 squared plus this guy F4 a couple of times. Oh, shoot. Function F4 a couple of times. Column A, there you go, squared. Parentheses divided by parentheses this guy squared plus this guy. Ta-da, ta-da, ha-ha. And I felt pretty good about it. If I didn't feel pretty good about it, you can always click here and double check to make sure you're calling the right x's and y's. We are, and lo and behold, the closer you get to 0, it's approaching 1. Obviously, you can't be 0, 0, but that's a problem. But that's another way you can do it. Hope that helps. Okay, so on this problem, you could write it this way, the girth one way or the other. I'm going to assume this guy here. So the height plus 2x plus 2h has to be less than or equal to 96 inches, right? So obviously max is going to be when it's actually equal to that. And so that's the key you want to kind of to play into there. So if you keep that in mind, you're going to have h is equal to 96 minus 2x minus 2h. Right, there's my x hanging out up there. Anyway, there it is. And so then your volume then, of course, volume is what? Well, volume is length, whereas height in our, right? God bless, this should be 2x plus 2h. Oh, this should have been L, dumbass. That should have been L. L. Sorry, there, man. What? Let's try that again, kids. Okay. I crossed out the wrong one. So the girth, let's just do the girth this way. The girth is equal to 2L plus 2x. That's the perimeter of one side. So that's this top, right? That's our top. 2x plus 2h. So then our girth, let's try this again. So then our height plus 2L plus 2x. It really doesn't matter because what we're going to see is it's going to come out to be all the same in a minute anyways. It is what you're going to notice in a second. So that's the guy I wanted right there. So h is equal to 96 minus 2L minus 2x. Again, the idea is, okay, now we need volume. So volume is x times L times h. Now we're kind of screwed because we need one to be a function of two variables. Like in Calc 1, we had one function was a function of another variable. And so now we can substitute. So now we have v is equal to x, L, and then 96 minus 2L minus 2x. There you go. And what you'll see, excuse me, when you multiply this out, 96xl minus 2xl squared minus 2x squared L. It wouldn't have mattered which one you do because it all come out in the wash, right? So you're going to end the same. You're going to get the same three numbers regardless, which kind of threw me off a little bit at first. Cause I'm like, I'm not going to get the same three numbers. Okay, there it is. So you need dv dx, which is going to be 96L minus 2L squared minus 4XL. dv/L rather is going to be 96x minus 4xl minus 2x squared, which again completely symmetric. Set them both equal to 0 and find our critical value or values. And so here we go. I'm just going to type in the original function and take the derivatives from there because, to verify myself. So the derivative of 96x times y minus 2x times y squared minus 2x squared times y with respect to x. Done. Which I think is what I had. And then with respect to y, I get that. Cool. And then I'm going to hit solve. This guy equals 0. And this guy equals 0, comma, squiggly brackets, x, comma, y. Oops. Squiggly brackets, parentheses. And you will find that 48, comma 0. Or 16 comma 16 or 0 48 16 0 48 and 0 0 are solutions. Well, I'm going to tell you right now, if these are side links, this isn't a box. This isn't a box. This isn't a box. It can only be these guys. So that's true then. If you think about it, okay, well, what does that say then? Well, obviously, x is 16. L is equal to 16. And then what is h? Well, if you plug it in, this is 32. this is 32, and 96 minus 64 is 32. So your box should be 16 by 16 by 32. As far as the other problem, I'm not really sure what that problem is asking for. Maybe you send a picture of the directions. It was something like z squared minus x squared divided by, I guess, 16 minus y squared. 9 minus 1 equals 0. I'm not really sure what that thing's supposed to be telling me. So you send me a picture of the instructions, I'll get you a better picture on that too.